Welcome friends, and in this video I'm gonna talk to you about Blaise Pascal's fluid pressure principle, and I'm gonna extend it to a vertical region submitted at a given depth on a fluid. Okay, so we're talking about So Blaise Pascal was a French mathematician. He lived in the 1600s. So he said that if you have let's say you have a tank, fluid tank, and then you have horizontals so let's say your depth is here, then Blaise Pascal principle says that if they're all horizontal, the fluid pressure at this depth, in other words here, if they're all horizontal surfaces, then that pressure says that the force of the fluid pressure is equal to the weight density of the fluid times the area. Okay, but Blaise Pascal is only works for horizontal surfaces, and we can extend this principle to vertical regions. Let me show you what I mean by that. So let's say you have a tank again, and remember, sometimes you ever seen the submarines, they have let's say you have a submarine or something, or like a vessel, and sometimes you have like a window submerged at a depth h, then let's say you want to find the fluid pressure of this side of the window, at the side of the window, then you cannot use Blaise Pascal principle, because this is a vertical region. It's a vertical, it's not a horizontal region. It's more, this, you can see this one is circular, so you have to use calculus to find such fluid pressure. So basically, the following definition that I wanted to give you is an extension of this principle for vertical regions. This is the vertical region. So let's say we had horizontal region, and then we cut it into n pieces, rectangular pieces. So then this one here, the height, the is delta y, and then we call it I because it's the ith rectangle. And then the depth at this point is we're gonna call it h of yi. And then the length of the horizontal region, we're going to call it L, Y, I. So this is the depth, this is the width, and this is the length. So then, to find the fluid pressure of such thing, there is a definition for it. So what you're gonna do, so weight is, W is equal to weight density of fluid. So the fluid could be water, it could be seawater, or other fluid. So then if we sum up, so for this region it could be any vertical region. So vertical, so then the pressure is equal to weight, the weight density times the sum. About to make it an exact, we're gonna take the limit of all. Okay, so I'm gonna tell you. Okay, so fluid pressure is gonna be equal to the lim as delta y approaches 0, or as n approaches 0, of the weight density times the sum from 1 to n. So we divide it by n pieces, but we're gonna let n approach infinity, or delta y approach 0. It means the same thing. And then we're gonna take that and we're gonna multiply hy, ly, and delta yi. But if we take the limit, this limit becomes, so let's say from here to here we go from C to D. So if I go from C to D on the vertical axis, this summation becomes the definition formula that says that the fluid pressure on the vertical region is equal to the weight density going from C to D of the depth times the length delta dy. So this is the final formula for fluid pressure. So thank you very much. Don't forget to subscribe, please.